Okay, welcome to Math 60, Section 2.6, solving geometry, problem solving in geometry. Sorry, would help if I could read. Okay, so geometric formulas for perimeter and area. Now, these are our standard formulas. In fact, they are included on SAT and ACT tests. Area of a square is S squared. That's basically the same as a rectangle, except for the L and the W are the same because a square has both the same width and length. Perimeter of a square is 4S. Of a rectangle, it's just the two lengths plus the two widths. Now in a triangle, we have 1/2 base times height. This is based on the fact that it is a half a square, right? So we have this distance and we have this distance. For a square or for a rectangle, your area would be length times width. For a triangle, it's half of it. Notice if I completed the square, it's half. So it's 1/2 base times height. So it's basically still based on the area of a rectangle. Perimeter, of course, is the sum of all three sides. A trapezoid. Now remember, a trapezoid is the one that has a smaller top and a larger base, or the other way around. And it looks something like this. It is 1/2 the height, that's the height, times the sum of the bases, the base and the other base, top and bottom. Okay, the reason for that is, okay, so what we're doing is we're creating a rectangle and we're averaging the two small side and large side in order to come up with the proper side length. Okay, so okay, let me see if I can explain that to you. All right, if I put another height right here, and I took this triangle, flipped it and moved it down here, I would now, with this as the other side, have a rectangle. The width of the rectangle would be the height of the trapezoid, and the length of the side would be the average of these two sides. Okay, because I took this little piece and I put it up over here. Okay, so that's how this works out. That's why it's this equation. All right, so let's look at examples. Find the perimeter and area of a rectangle, 3 feet by 4 feet. Okay, these are always easier if you draw them out. 3 feet is the shorter length, 4 feet is the longer. So the perimeter means the distance around the whole thing. So it's going to be 3 feet plus 4 feet plus 3 feet plus 4 feet. So 3 plus 3 and 4 plus 4. All right, both sides. That's why it's 2 widths plus 2 lengths. Okay, so this is going to be 8 and 6 is 14 feet. Perimeter is a linear number, so it's just feet, not feet squared. Area is where we get into feet squared. So we have basically 3 rows of 4. Okay, they're not very even, but they should be 3 rows of 4 to get our square area. So it's 3 times 4, which is 12. Now it is square feet. Okay. Find the area of a trapezoid that has bases of 26, so that's our 26, and 37. But its height is 18, which is what we needed to know. Okay, so it is, the area is equal to 1/2 the height times the sum of the two bases. So I have an area is 1/2, my height is 18, and then 26 plus 37. Okay, so 1/2 of 18 is 9. 26 and 37 is 50, 63. So we're just going to multiply those two numbers. 9 times 63. 567. Square meters. Okay, now we're going to talk about circles, circumference and area. Pi r squared is your area. Circumference is 2 pi r, or sometimes you can refer to it as pi d. Because d is 2r. R is the radius, d is the diameter. Radius is half of your diameter. Find the area and circumference if the circle has a radius of 9 meters. So area is pi r squared, which in this case is going to be pi times 9 squared. This means it's 81 pi. Okay, 81 times pi is 254 point, well, let's see. We're going to do one decimal place. So 6, it's going to round up to 5. 0.469, and it rounds up to 5. Okay. Square meters. Okay, and our perimeter, which is our circumference, is 2 pi r, which is 2 times pi times 9, or 18 pi. So we're going to do 18. Now when I teach trig, I prefer it to be left as 18 pi because that's exact. But we're not that high, so we're just going to do a decimal and round it to one decimal place. 5, 4, so it's just 5. 56.5 meters. Again, this is a distance, so it's linear and not square. Okay, area has the square units. Find the area of a circle with a diameter of 40. Well, this means that r is 20, right? Because it's a diameter. You have to be careful. So a is equal to pi r squared, which is equal to pi times 20 squared, which is 400 pi. The circumference is 2 pi r, which is really pi d, so we can use d for this one, so it's just 40 pi. So now we have to multiply these. 40, pi is 125.7 feet. For 100 pi, should be that with one decimal place moved over. So it rounds down to 6. It's 1256.6. Now this time it's square because it is area. Right? We squared the radius, which is feet, so we squared the feet, so we have square feet. All right. It's all logical. You just have to see the patterns. All right, formula for the volume of 3D solids. Okay, a cube is side cubed. Okay, so I'm going to draw you some pictures here. You get to evaluate my drawing skills. So a cube, each of these sides is the same length. Right, so this is also the same length. All right, so it's just 3 of them multiplied together. For a rectangular solid, so this is more a prism. There we go. we have the length, the width, and the height. Now a circular cylinder is like a can. Okay? Now there's a radius for the bases. And we have radius times height. Height is this distance, and of course your radius is that thing in there. All right, a sphere, that's just a big gigantic earth, right? A ball. So usually what we do is we go with dots here, and then we draw a straight line around along here. Like that. Okay, sphere. From the center of the sphere to the edge is a radius, 4/3 pi r cubed. All right, a cone, all right, has a circular base, but it comes to a point. It has a height and a radius. Okay, now you kind of get an idea of where all these numbers are. All right, so let's look at this. Find the volume of a sphere with a diameter of 24 inches. So sphere is 4/3 pi r cubed. Nope, not area. Volume. 4/3 pi r cubed. In this case, this is a diameter, so r is 12, half of that. So I have 4/3 times 12 cubed, and then pi. Okay, so I'm actually going to do 4 times 12 cubed times pi divided by 3. And that's how that's going to work, because you can think of each of those whole numbers as being over a 1. Okay, so we have 4 times 12 cubed pi divide 3. We get 7,238.2 cubic this time inches. You can just do CU for cubic. Find the volume of a cone with a height of 60. Okay, volume of a cone. Let's write that down first. Sorry. Volume of a cone is 1/3 times the area of the base, which is pi r squared, times the height. Okay? So, it's going to be 1/3 pi. R is 5. 5 squared is 25. Times the height, which is 16. Okay, so again, I'm going to do pi times 25 times 6, 16. So pi 25, 16, and then divided by 3. 418.9 cubic meters. All right, angles of a triangle. The sum of the measure of the three angles of any triangle is 180 degrees. Okay. Apparently we have two triangles. We're going to look at number one. One angle of a triangle is 3 times as large as another. Okay, so let's draw ourselves a triangle. One angle is 3 times as large. So I have x and 3x. And this is the largest and this is the small. The measure of the third angle is 40 degrees more than that of the smallest. So this one is x plus, nope, not 30, 40. X plus 40. So we know that 3x plus x plus 40 has to equal 180 every time. So I have 3, 4, 5 x's. 5x plus 40 is 180. So I'm going to subtract the 40. I have 5x equals 180 minus 40 is 140. Divide by 5. X is 28. So find the measure of each angle. So angle 1, 28 degrees. Angle 2 is 3 times that. So that's 60, and then 3 times 8 is 24, 84. And angle 3 is the 28 plus 40, which is 68. Okay, those are our 3 angles. Okay, one angle of a triangle is 3 times as large as another. Didn't we just have this? So angle 1 is x. Angle 2 is going to be 3x. The measure of the third angle is 30 degrees greater, so this is x plus 3. That's angle 3. Okay, so we have x plus 3x, not x plus 3, x plus 30, plus x plus 30. That all has to add up to 180. So I subtract the 30 and I get the x's together. So I have 3, 4, 5. And 180 minus 30 is 150. Divide by 5. X is 30 degrees. Okay, so angle 1 is 30 degrees. Angle 2 is 90 degrees. Angle 3 is 30 plus 30, which is 60 degrees. And there we go. All right. Geometry, how fun. Complementary and supplementary angles. Complementary angles, the sum of the measure of 2 angles is 90 degrees. Well, for this to be true, I don't know if you remember all the definition of the different types of angles, but an acute angle is an angle less than 90 degrees. So, complementary angles, they both have to be acute. Now, the way to remember that is your acute little angle. So the 2 little angles add to 90. So that's acute angles. Okay? Complement, they're complementing each other. One is saying, you're a cute little angle, and the other one's saying, you're a cute little angle. I know that's really silly, but it helps me remember, and that's really what we have to do, right? Okay, so they're complementing each other. They're complements. They make a 90-degree angle. They're both the small ones. Supplementary means that they have to do the splits. They add to 180. Aligned, this distance is 180. So if you think of a person sitting here, they have to do the splits, right? They're making a line with their legs. So they have to be supple to do the splits. Supplementary is straight line, 180. Okay, so a little silly, but it might help you remember. What is the measure of the complement? So 90 minus 41. They have to add to 90, right? So it's 41 plus my x. Oops. Okay, we'll put a little plus there. So really, it's x is 90 minus 41. So x is 49. Okay, 49 degrees. What angle's measure is 78 degrees less than its complement? Again, that means they have to add to 90. So we're going to find it by doing 90 minus the 78. So 10 to get down to 80 and another 2. So x is 12 degrees. And there we are. Okay. Hopefully that helps you remember all those silly little geometry things. We need to get moving. All right. Okay, and that's the end of 2.6. See you tomorrow.